Welcome to Hexagon Tutorials Dart series. In this video, we will learn about exception handling in Dart, how to manage errors effectively, prevent crashes, and write more robust code. An exception is an error that happens while a program is running, causing it to stop unexpectedly. In Dart, exceptions are used to indicate that something went wrong during execution. Let's look at some common situations where exceptions can occur. Imagine trying to divide a number by 0. Mathematically, that's undefined, so Dart throws an exception. Another common case is accessing a null object. If we try to use something that doesn't exist, the program crashes. Parsing errors can also cause exceptions. For example, if we try to convert the text ABC into a number, Dart won't be able to process it and will throw an error. And finally, file not found errors. If we try to open a file that doesn't exist, the program won't be able to continue as expected. These are just a few examples. But understanding exceptions is key to writing stable and error-free applications. In this Dart program, we attempt to perform an integer division by 0 using the integer division operator. However, since division by 0 is mathematically undefined, Dart throws an error. To prevent this, we use a try-catch block. The try section contains the risky operation, and if an error occurs, the catch block captures it and prints a custom error message instead of stopping the program abruptly. As a result, instead of crashing, the program gracefully displays an error message. This method ensures that the application continues running smoothly even when unexpected errors occur. Using try-catch is an essential best practice for handling runtime errors in Dart programming. In Dart, the catch block is used to handle errors, and the variable E represents the exception that occurred. When an error happens inside the try block, Dart automatically passes the error details into E. This helps in identifying what went wrong and allows us to print or log the error message for debugging. For example, when we try to divide by 0, Dart throws an error saying unsupported operation, infinity. The catch block captures this error in E, allowing us to display a user-friendly message instead of crashing the program. Using E is important because it gives us insight into the type of error, making it easier to handle different exceptions in different ways. This helps in writing more robust and error-free Dart applications. In this program, we are using a try-catch finally block to handle errors. Since division by 0 is not allowed, an error occurs, and the catch block captures it, displaying an error message. Despite the error, the finally block executes, printing a message that runs no matter what. Next, we modify the program to perform a valid division. This time, since there is no error, the catch block is skipped, and only the result is printed. However, the finally block still runs, proving that it always executes regardless of whether an error occurs. The finally block is useful for tasks like closing files, releasing resources, or executing cleanup operations that must happen no matter what. In this Dart program, we attempt to convert a non-numeric string into an integer using the int.parse method. Since the string does not contain a valid number, Dart throws a format exception. To handle this, we use an onFormat exception block, which specifically catches formatting errors. When this error occurs, it prints a message describing the issue. Additionally, we include a general catch E block to handle any other unexpected errors. However, in this case, since the error is a format exception, the first block executes, displaying the message. Using specific exception handling like onFormat exception is a best practice because it allows us to manage known errors separately while keeping a general catch block for any other exceptions. In this Dart program, we have a list containing 4 numbers. Inside the try block, we attempt to access an index that does not exist in the list. Since the index is out of bounds, Dart throws a range error. To handle this, we use an onRange error block, which catches the specific error and prints a message indicating that the index is out of range. Additionally, we include a general catch block to handle any other unexpected errors. However, since this is a range error, the specific handler executes first. In this Dart program, we have an empty list and attempt to access the first element using the .first property. Since the list has no elements, Dart throws a state error. To handle this, we use an onStateError block, which specifically catches the error and prints a message indicating that the list is empty. Additionally, we include a general catch block to handle any other unexpected errors. However, since this is a state error, the specific handler runs first. Handling such errors ensures that our program doesn't crash and provides a clear message when an operation is attempted on an empty list. In this Dart program, we have an empty list and attempt to access the first element using the .first property. Since the list has no elements, Dart throws a state error. To handle this, we use a try-catch block. The catch block captures 2 parameters, E, which holds the error message, and stack trace, which provides detailed information about where the error occurred in the code. The stack trace is important because it shows the sequence of function calls that led to the error, the exact file and line number where it happened, and the execution order before failure. This information is essential for debugging, especially in large applications, as it helps pinpoint the source of the issue. By logging stack traces, developers can track and fix errors effectively, making the program more reliable and user-friendly. In this Dart program, we define a variable age with a negative value. Since age cannot be negative, we manually throw an argument error inside the try block when the condition is met. Throwing an error like this helps enforce data validation and prevents invalid values from being processed. When the error is thrown, the catch block captures it and prints an error message. Using throw statements is useful for handling invalid input, enforcing business rules, and ensuring that the program does not continue with incorrect data. This approach makes the program more robust and prevents unexpected issues from occurring later. Let's do a quick recap of what we've learned about exception handling in Dart. First, exceptions help us handle unexpected errors in a controlled way, preventing our program from crashing unexpectedly. Instead of stopping execution, we can catch these errors and respond appropriately. Next, we use try-catch finally to manage errors gracefully. The try block contains the code that might throw an exception, the catch block handles the error, and the finally block ensures that important cleanup tasks like closing files or releasing resources always run whether an error occurs or not. It's always a good practice to catch specific exceptions instead of using a general catch-all block. This allows for fine-grained control and helps us handle different types of errors appropriately. For example, catching a format exception separately from a range error ensures we respond correctly to each issue. We also have the ability to throw custom exceptions using the throw keyword. This is useful when we need to enforce specific rules in our program, such as validating user input or preventing invalid operations. And finally, always remember the finally block. It's essential for cleanup operations like closing database connections, freeing up memory, or logging errors, ensuring our program remains efficient and stable. By implementing these best practices, we can write more robust and error-resilient Dart applications. Thanks for watching. Stay tuned for the next video, and don't forget to like, share, and subscribe.